Hi all, let us try to attempt PSPM 2011-12 for the chapter heat, and is about section A and section B only. For the section A, Roman 1, define the coefficient of linear thermal expansion. You're going to get only 1 mark for define this definition out of 4 marks for this section. You have two options to define by writing the equation of change of length equals to coefficient of linear thermal expansion times the original length times the change in temperature, and put it the alpha is a subject and define all the symbols like what I'm mentioning just now, where alpha is coefficient of linear expansion, del L is change in length, L naught is original length, and del T is change in temperature. Or you can define it in this way: coefficient of linear expansion is change in length per unit rise in temperature. Simple like a bubble without giving you any trouble. For Roman 2, a pair of eyeglass frame is made of epoxy plastic. At 20 degrees Celsius, the frame has circular lens holes of radius 2.2 cm. If the coefficient of linear expansion of the epoxy is 3 times 10 to the power of negative 4 per degree Celsius, to what temperature must the frame be heated so that a lens of radius 2.21 centimeter fits the frame? For this section, it carries 3 marks. Just now is 1 mark. For this part is 3 marks. According to the questions, the original temperature or initial temperature is 20 degrees Celsius. The final radius is 2.21 centimeter. The original radius or initial radius is 2.20 centimeter. And the coefficient of linear expansion of the epoxy is 3 times 10 to the power of negative 4 per degree Celsius. And the question is about to what temperature must the frame be heated so that a lens of radius 2.21 centimeter fits the frame. Again, we have two options to find this temperature. For the option 1, we have to assume the final radius is equals to the length and the original initial radius equals to the original or initial length. So by using this equation, change of length, which is equals to alpha times L naught times del T, and we're going to substitute all the values accordingly into that equation. And please take note for these two parts, no need to put in meter because the centimeter cancel each other. So once you substitute all the values or substitute all the values, you will get the change of temperature is 15.2 degrees Celsius. So the change of temperature is final temperature minus initial original temperature. So the temperature which fits the frame is 35.2 degrees Celsius, or you can put it into Kelvin, which is equals to 308.2 Kelvin. Simple like a bubble without giving you any trouble. And for the option 2, as I said, we have two options. We're going to use coefficient of area expansion. By using change of area equals to beta times the original area times the change in temperature or rise in temperature. Again, by substitute all the values accordingly into this equation, So we're going to substitute all the values into this equation. By putting beta equals to 2 alpha, the relationship between linear expansion and area expansion, we're going to substitute all the values in this equation by putting beta equals to 2 alpha. So you can see how I substitute all the values. You can cancel pi and centimeter both sides. And the change in temperature is 15.2 degrees Celsius. And it is exactly same for what we did it before in option 1. So you will get the temperature is 35.2 degrees Celsius, and again for the Kelvin is 308.2 Kelvin. So you can put it in degrees Celsius or in Kelvin. Again, it is simple like a bubble without giving you any trouble. So for the section A, we already claimed 4 marks. Let us go to section B, which is going to give you 5 marks. An insulated spherical glass, bulb of radius 2.5 cm, thickness 0.4 mm, whose outer surface temperature is 30 degrees Celsius, dissipates 55 watt of heat. For B Roman 1, given the thermal conductivity of glass is 0.84 joule per second per meter per degree Celsius, calculate the temperature of the inner surface of the bulb. Joule per second here is watt. It's about power or rate of energy change. By digging out all the information in the questions, which is the radius is 2.5 cm, which is equals to 2.5 times 10 to the power negative 2 meter. The thickness is 0.4 millimeter, which is equals to 0.4 times 10 to the power negative 3 meter. And the rate of energy change is 55 watt, or dissipates 55 watt of heat at the temperature 30 degrees Celsius. So this is going to be the final temperature. And area for the spherical glass is 4 pi r square. So now you're going to substitute all the values accordingly into this equation. So make sure you well substitute all the values, and again make sure your algebra is not algebra, because you have to find the dt. Press the calculator properly to get the dt. If you don't have the calculator, you can calculate later. So your dt, change in temperature, is negative 3.3 degrees Celsius. Therefore, the temperature of the inner surface of the bulb is 33.3 degrees Celsius. Simple like a bubble without giving you any trouble. For the B Roman 2, sketch a labeled temperature against distance graph of the heat conducting through the bulb. Remember, it is about an insulated spherical glass. The bulb is well covered or well insulated. So no doubt you will get a straight line where the temperature is constantly decreased for the distance x. For the initial temperature is 33.3 degrees Celsius, final temperature 30 degrees Celsius, and for the distance 0.4 times 10 to the power negative 3 meter. Thank you for watching this video. Thanks a lot, and thank you to the Lord.